Welcome back. In this segment, we will be discussing how we can develop a production plan, or in other words, how we can make the supply plan in an S&OP process. So there are four basic strategies to make the production plan. We are having production leveling strategy, chase strategy, subcontracting, and hybrid strategy. In this course, we will be focusing on the first two. And specifically in this segment, we will be discussing how we can make the production plan using production leveling strategy. And we will solve uh, S&OP grid for making a production plan for a make to stock environment using production leveling strategy. So what is a production leveling strategy? It is a process of continually producing an amount equal to the average demand. So that is the core. Sometimes practically the demand is less than the amount produced and an inventory builds up, and at other times demand is greater and inventory is used up. Now the advantages of this strategy include that it results in a smooth level of operation that avoids the costs of changing production levels. So you could standardize your production process. No need to have excess capacity to make peak demand. So the peak demand is actually met through the inventory that was built up during off-peak period. No need to hire and train workers and lay them off in slack periods. So you could standardize the production processes, the number of workers required, the number of machines required, etc. Now, the main idea behind production leveling strategy is inventory. And that could be a disadvantage as well in a sense. So inventory will build up in low demand period that will cost some money to carry. So you have to have, for example, sufficient storage capacity in order to keep the inventory safe and then use it during the peak periods when the demand increases. So this is the basic idea that demand keeps on changing. Sometimes it is less, sometimes it increases, it reaches a peak and then reduces. So it could be something like this. So it is not constant. So one option is to match this variation in the demand. So that is called the chase strategy. But other option is to keep the level of production constant, something like this. So for example, in this case here, in these 6 months in this illustrative graph, the demand is less than the production. So inventory will build up and this inventory will be used somewhere over here when the demand is greater than the capacity. So that is the basic idea behind production leveling strategy. But keep in mind that this strategy is used for the products where this variation is not too much. So generally there are random variations in demand or there are seasonal variations in demand, but they can be met through the average quantity that is produced. So how much should be produced? So that is the basic question. What should be the average quantity that we should be producing in each period? So that is equal to total forecast for the planning horizon, sum of the forecast for the planning horizon, minus opening inventory before the planning horizon, plus planned inventory at the end of the planning horizon. So that is the basic idea. So that is the net quantity that you have to produce. Divided by number of periods. So that will give you an average quantity that should be produced every period. So this period is generally a month. We will be discussing for months, but it could be other time units as well. You could make, for example, the level production plan for daily basis as well. So these are important formulas. We have discussed the first one. Now, the basic parameter in level strategy is the inventory that you are carrying. So actual inventory in a period T is equal to actual inventory from previous period, period T minus 1, plus actual production in this period minus actual sales in this period. So these two quantities show what you are having in terms of inventory from previous period plus what you are producing in this period. So actual inventory from previous period plus actual production in this period, the current periods. So that is something that you're having minus actual sales, something that you have actually delivered. So that is actual sale. So that results in the actual inventory that you are having in this period T. Now, this inventory can be converted into inventory in days. So that is called days on hand. So days on hand is this actual inventory in that specific period divided by daily planned production. So this is daily planned production. For example, if you are having certain inventory uh, at the end of May, now how much this inventory is equal to with respect to planned production for the month of June. Or in simple words, the demand of how many days can be met from this inventory that we are carrying in May. So this inventory can meet the demand for how many days for June. So that is the basic idea. So days on hand is equal to this actual inventory divided by daily planned production. And daily planned production in a certain period is equal to planned production in that period divided by number of days in that period. So we will see the calculations using Excel. Another important formula that is regarding the number of workers or machines, that formula is important because whenever we are making the plan, we are uh, checking its validity or its feasibility against available resources. So that is called resource planning. So for resource planning, we do need to know how many workers or machines or equipment will be required. So that is equal to daily demand or workload divided by daily capacity or available time. So this demand and capacity could be in terms of number of units or it could be in terms of time. So both will result in the same quantities. So we will now see these formulas in action using Excel. And I would reiterate that production leveling strategy is appropriate for make to stock products where the variation in demand is not too much from period to period. So this is an example of sales and operations planning grid for a make to stock production environment using production leveling strategy. So we are having the data related to the sales, production and finished goods inventory. And we are having the forecast for certain periods, in this case for the next 12 months. Then we have to compare this forecast with the actual sale and then calculate the difference so that we can keep an eye on what is the difference between actual sales and planned sales or forecast. Then we are having planned production and actual production, and we could see the difference between actual and planned production, and we could keep an eye on whether the difference is within acceptable limits or not. And then again, we are having some quantity of planned inventory. Then there will be actual ending inventory at the end of each period. So we could see the difference here as well. And finally, the ending inventory at the end of a certain period, somewhere over here or here, can be converted into inventory on hand for the next period. For example, actual inventory at the end of, say, February, some quantity here can be converted into inventory in terms of uh, inventory number of days for the next period. So for example, this inventory could be converted into inventory in terms of days for March. So ending inventory for February can be converted in terms of number of days for the requirements for March and so on. So we will see these calculations with the help of an Excel spreadsheet. This is the same grid, S&OP grid for a make to stock environment using level strategy as we saw in the slides. So we are given the forecast for the next 12 months. We have to convert these quantities in an average amount that we should be producing every month. So first we have to add these forecast quantities. So that is the sum of the forecasts. Now, the production plan or average quantity that we plan to produce every month will be equal to sum of these forecasts minus starting inventory that we are having uh, before this planning horizon. So that is 1150 plus what we plan to have at the end of the planning horizon, that is by the end of December. So in this case, the organization is having a plan to have 1000 finished products at the end of every month. So that will be the quantity at the end of December as well. So that is the net quantity that we have to produce. That is the total quantity that we have to produce during the next 1 year. So that is the net quantity, total forecast minus what we are having plus what we plan to have at the end of December. So where we are having 12 periods, so we have to divide by 12. So that will give us an average production quantity of 2050 every month. So I repeat that we could have a level strategy for daily production instead of for average monthly production. So both can be done. Now, practically, you have to convert this quantity for every month into number of products to be produced every day. So that will depend upon the available days. So we are assuming that on average there are 20 working days uh, every month. So this is the average quantity to be produced every month. So that is the planned production. So that is 2050. So this is something that has to be produced every month. Now let's assume that the current period is May and we have had actual sales up till April. So for example, a certain quantity in January, certain quantity in February, then in March, and then in April. So these are the quantities of actual sales for the first 4 months. Similarly, we could have actual production as well. So for example, we produced such quantity of 1950 in January, 2000 in March, 2000 in February, 2000 in March, and 2150 in April. So you could see there is some difference between what we planned to produce and what we actually produced. Now we could calculate the difference of the plan and the actual sales and production, and so that we can have a sort of a check on whether we are having the difference within acceptable range or not. So first we have to calculate the monthly difference of sales. So that will be equal to actual sales minus forecast. So actual minus forecast. So that is also called forecast error, as we discussed in our module on demand forecasting. So we are having the data for actual sales up till April. So we can drag to calculate the difference for that is the difference of actual sales and forecast, actual minus forecast. Now we have to calculate the cumulative difference as well. So what is the difference of actual sales and forecast for a number of periods for 4 months that we are having the actual sales for at the moment? So that will be equal to, we can use the formula for sum. So this difference, and then we can use colon. So at the moment we are having only one difference, so that will be sort of 150 plus 0. So we can fix the first cell, that is cell D9 in this case. And at the moment we are having sum from D9 to D9. And as we will drag, we can calculate the cumulative difference for the rest of the months as well. So you can fix the cell D9 by pressing F4 key on your keyboard. So as I drag, I will be able to calculate the cumulative difference for the rest of the months as well. So you could see that here we are having the sum of D9 and E9 here, from D9 to F9, and here from D9 to G9. Similarly, we can calculate the difference as a percentage. So that will be equal to this cumulative difference divided by sum of actual sales. Again, we can use the column and we can fix this first D8 cell by pressing the key F4. So that will give us the cumulative difference between actual sales and forecast as a percentage. So that is 6.98% for January, 2.44 for February, and so on. So, of course, this difference should be as less as possible. Now, for this part of the grid, for the production, we can calculate the difference of actual and planned production. So that will be actual production for January minus planned production for January. And then we can drag to calculate the difference for the rest of the months. So by now we are at the start of the May, so we can make these calculations up till April. Then the cumulative difference of actual production and planned production. So that will be equal to sum of the monthly difference. So we can use the colon again. So we are having only one difference. We will be fixing the first D16 cell here, and then we will be dragging to calculate the cumulative difference for the rest of the months. So up till April, we are having a cumulative difference of minus 100. So as a whole, the actual production has been less than the planned production, equal to 100 units. Then the difference as a percentage, so this cumulative difference divided by sum of the actual production, use colon, fix first cell D15 in this case. So the cumulative difference as a percentage has been minus 1.23% up till the month of April. So as a whole, the actual production has been less than the planned production for the first 4 months. So as a whole, the actual production has been less than the planned production for the first 4 months. Similarly, we can make calculations for finished goods inventory. So organization has a policy to have on average 1,000 products at the end of each month. So first we have to calculate the actual inventory. So actual inventory will be equal to actual inventory from previous period plus actual production in current period. So that is something that we are having in the form of inventory in this period, minus the actual sales, something that we have delivered in this period. So that is the actual inventory of 950 that we will be having at the end of January. So we can drag to calculate the actual inventory for the rest of 3 months. So we are having inventory 1,000 at the end of February, 800 at the end of March, and 800 at the end of April. Now we can calculate the difference of actual and planned as we did for sales and production. So that is monthly difference. So again, the actual inventory that we are carrying as a whole is less than what we plan to carry. We can calculate the cumulative difference. So again, we can use the function of sum, and we can use the colon, then we can fix the first cell, and then we can drag. So the cumulative difference is minus 450. And this difference as a percentage will be equal to this cumulative difference divided by uh, the sum of actual inventory up till a certain period. We can use colon, we can fix the first cell. Sorry. So this cumulative difference as a percentage, sorry, there is some error. So let me repeat. So the cumulative difference as a percentage will be equal to this cumulative difference divided by sum of actual inventory up till a certain period. So we are in January at the moment. So cell D22, we will be fixing the first D22. And then we will be dragging for the rest of the months. So the cumulative difference as a percentage is minus 12.68% by the end of April. Now, the important question we have to answer is that how much this actual inventory is worth the planned production for the next period. So, for example, this actual inventory of 950 is worth how much the demand for the month of February. So, for that, we have to convert this inventory into the demand in terms of number of days for the next month. So, that will be equal to this 950 divided by daily planned production for February. So the monthly planned production for February is 2050. In order to convert it into daily planned production, we have to divide by the working days for that month. So we are assuming the working days to be 20. So actual inventory for this period divided by planned monthly production divided by number of days for the next month. So that will give us an inventory worth 9.27 days. So we can say that this inventory of 950 is worth 9.27 days of planned production for the month of February. But in simple words, this inventory of 950 can meet the demand of about 9 days for the month of February. So we can fix this cell of 20 that is containing the working days of 20 per month in order to carry on this calculation for the rest of the months. So we can calculate the inventory in terms of number of days. So this inventory of 1000 at the end of February is worth the planned production of 9.76 days for the month of March, and we can similarly see for the other two values. So this ending inventory of 800 is worth 7.8 days of inventory for planned production of 2050 for the month of May. So now we have made some of the calculations related to the plan using level strategy. So we have seen the sales plan, production plan, and finished goods inventory, how we can make calculations for these three elements of the plan. We also need to calculate the number of resources required, and that is called the resource planning. So in order to illustrate the idea here, we are calculating the number of machines required in 3 departments. So the formula to calculate the number of machines or number of resources is demand over capacity, workload over available time. So demand per day can be calculated as monthly demand divided by number of working days per month. So 2050 divided by 20 will give us average daily demand of 102.5. So now in order to calculate the machines required, so we will be using a formula of demand over capacity or workload over available time. So in this case, we are not having the data in terms of time. So we will be using data in terms of number of units. So daily demand in terms of number of units is 102.5 and daily capacity in department 1, the capacity per machine per day is 10 products. So I repeat, it will be equal to daily demand divided by daily capacity. So number of machines required will be 10.3 or approximately 10. Similarly, for department 2, daily demand divided by daily capacity per machine. So that will give us 5 machines required for department 2. And similarly, for department 3, daily demand divided by daily capacity per machine. So that will give us around 21 machines. I hope you have got a basic idea how we can solve an S&OP grid using production leveling strategy. So 3 important components were sales, the production, and finished goods inventory. And we can calculate the difference in order to make a sort of dashboard and set the limits of the cumulative difference so that once the limit exceeds, we can make the adjustments as required. And we made some sample calculations for the number of machines required. One of the important inputs, as you might have noticed in this S&OP grid, is the sale forecast. So that runs actually the rest of the calculation, because based on the sales forecast, we calculated the average quantity that we have to produce, and then rest of the calculations were made. In the next segment, we will solve the S&OP grid for a make-to-order production environment using Chase strategy. Thank you.